guys. Because I get a lot of questions about this, I just kind of want to explain a little bit more about what's going on with the object on a slope, and why we can break up the angles the way that we do. Okay. All right, so I'm just going to kind of draw a line through the box to sort of represent. So, okay, when we have an object on a slope, it's actually usually easier for us to think of things we want to put one coordinate direction in the direction of acceleration. So we usually choose this to be like our x-axis for an object on a slope, and we often choose this to be our y-axis, right? So it's kind of like skewed. But then notice we have this this angle up from the slope, so that this this x-axis here, right, is also kind of, it's tilted up by this angle theta, right? Because this is going to be parallel, right? This line is going to be parallel with the slope. That's what we want for x. We want it to be parallel with the slope. Okay, so then when I draw my force vectors, what does that mean about how I break things up? Okay, so first, I want my object acting from the center of the weight acting from the center of gravity of the object. Okay, so I have my weight. It's going to be acting down, right? If we kind of think about that. So just draw a dotted line down there. And then I want my normal force is going to be acting perpendicular to the surface. Okay, so this is my normal force, and we're perpendicular, right, to the surface the object is touching. So when an object with mass is touching a surface, that surface is going to, or pressing against a surface, it's going to exert a normal force, okay? So like an opposing force, so that it doesn't like go through the surface basically. Okay, so now that we've got things set up, now let's think about like why that angle over there is theta. Okay, so you know that this is a right angle here. Sorry, and I drew this in black. Let me maybe do the same color here. And this is like a parallel line, our x, right? Our x line is parallel to the slope, right? So it's up at that same angle. Okay, so then what is this angle here, right? This angle here is going to be 90 minus theta, right? Because the triangle has 180 degrees for the whole triangle. This angle is 90 degrees, right? This angle is theta. So this one is going to have to be 90 minus theta, right? So then what does that mean? Well, we know that the x and y pieces are perpendicular to each other, right? So then that's why this angle here is also just theta, okay? So when we have a slope with an angle of theta here, we know that the angle between the normal force and the weight is also going to be theta, right? The same angle of the slope. So hopefully that helps kind of clear things up a little bit. I'm going to keep going. If that answers all your questions, you can feel free to move on. I'm going to add a friction force and then just show how you break up sum of forces, okay? So the friction force is going to act basically preventing the, it's against the direction of motion. So imagine if this is sitting on the surface and it's going to try to slide down because that weight vector is going to point this way, that frictional force is going to go against the direction of motion, okay? How do we break up our weight forces? Well, let me move my weight down. Okay, just a quick note on direction, right? We have to think about what direction the vectors are going when we break them up. So our weight is going to go right down, got this negative y, and then over. So this would be wx, and this would be wy. So we can take any vector and we can break it up into x and y components. So w is going to be equal to wx plus wy, right? We can take any vector and that vector is going to be equal to the sum of its x and y components, right? Okay, because we can either get there by going, you know, from here to here or going down and over, we're going to get to the same point. Okay, so now when we add things up in the x and y direction, what does that look like? Okay, let's do sum of forces in the x and sum of forces in the y. Okay, so when we do sum of forces in the x and y, we're going to look at our line, our coordinate line, and say what vectors are pointing along this direction, and then we're going to look at our other coordinate line and say what vectors are pointing along this direction. Okay, so for sum of forces in the x, what vectors are parallel with this line? Well, the frictional force is parallel, and then the weight force is parallel. Those are the two vectors that are parallel. Okay, because we want to use the broken up weight vector. So friction is going to be pointing, oh, that's our positive x, we chose that to be positive. And then w is going to be pointing in our negative x. So you can choose whatever positive or negative direction you want for your problem. Just make sure that you indicate it with like a coordinate system. Okay, to avoid any confusion. Okay, so just use your assumptions. So I kind of already wrote a little bit of a coordinate system here, so I'm just going to write positive to make that clear. Okay, so all of the vectors parallel with x. So I have the frictional force, right? Maybe I should use the same colors, I guess. So I have the frictional force, and I just chose that to be positive. You could choose it to be negative, minus wx. Okay, now, anytime I do sum of forces, I am using force is equal to mass times acceleration. So I'm summing all of the forces, and then I'm looking at that direction and asking myself if there is any acceleration in that direction. For this problem, we're going to say that yes, that there is acceleration in this direction, right? Because if we have a block on a slope, it's going to be accelerating down. We have a force going in that direction, that weight force, and it's not balanced, and so it's going to be going down that slope. So we need to understand the behavior of the system. So we're going to try to find the acceleration along the slope. It's possible that there wouldn't be acceleration. I'm just going to assume in this case that there is. If there was a problem statement, you want to read the problem statement carefully. It'll tell you if there's acceleration along the slope. But this block could be not moving if this friction force was large enough to be equal to the weight. Okay, but we're going to say that we're going to set this equal to MAX, right? And notice because this is positive, my block is going to be accelerating down the slope. So I'm going to say this is equal to negative MAX. So you can see here, it kind of doesn't really matter what you choose to be positive or negative for your directions. It'll work out based on kind of what you assume. Okay, sum of forces in the y. I have the normal force pointing up, right? I have that normal force, and then I have minus wy, right? Minus wy because it's pointing down, okay? And that's going to be equal to what? Do I have any acceleration along this y line, right? Is the block going to leave this surface, or is it just going to move along this x line the whole time? So I don't have any change along this y line. It's just going to move down this plane throughout from point 1 to point 2, which is what I'm looking at for my problem. So I'm going to say, so this would be MAY. AY is 0, so this is equal to 0. Okay. So now I could do some algebra and figure out different things about my problem. I know one thing I just want to point out here at the end. So if I want to solve for Wx, remember that this Wx is across from this theta, right? So sine is across. So this would be W sine of theta. My Wy is going to be adjacent to the angle. See, this is my angle and my Wy is adjacent. So Wy is going to be equal to W cosine of theta. Okay, and I would plug those into my expression below. So this is just kind of an overview on how I would set up my vectors for something on a slope and why exactly I'm doing that.